In our previous videos, we learned how to do CIP SIP messaging from a Micro 800 to another Micro 800, both reading and writing. In this one, we're going to talk about how you can pass data between Micro 800 PLCs through Modbus TCP. These can be a Modbus TCP server or a Modbus TCP client, which gives them a lot of flexibility. Now we are picking up where we left off in our Festo Didactic Mech Lab video series. If you're coming into here and you are not watching this series, then it's okay. We're going to walk you right through Modbus TCP. But if you are going through our series, we took our handler, and that's what we're talking with SIP messaging to our main PLC. And then on this one, we're going to make our Conveyor PLC read and write over Modbus TCP. Now, I am going to make the Conveyor our Modbus server. I'm going to make our main PLC the Modbus client. It really doesn't matter for this application, but we already have our SIP messaging instructions in this, so it just made sense to put our Modbus message instructions in it also. So let's go ahead and right-click our connected components and open up a third instance of it and click New. And very important at this point, we have 4 PLCs we're working with on this project, so they need good names. This is going to be my Festo middle conveyor. And open up controllers, and this will work with the Micro 820 through Micro 870 controller. We have a Micro 850 L50E, that's a 2080 L50E 24 QBB. Select. Add to project. We're going to do the exact same mapping as we did do in the previous video. So for those who are just coming here trying to learn about Modbus TCP, we took all of our inputs and we took them to inputs from main PLC, and all of our outputs are being controlled off of outputs from main PLC. And let's just go edit, select all, right click, copy. And let's go to our new program. And, I need to create a program first. So let's right click, add ladder diagram, open it up, and right click and paste. And there you go. All right, now we have some errors, and that's because we need to create our data tag. So let's double click just on one of the output energizes. And remember from the previous video, we can actually do work in here without hitting the OK button. That's what we're going to do here. We're going to take the bracket 0 bracket dot 0 out of it. And then for our data type, we're going to make it a dent. And then we need that dimension. It's going to be 0.9 because we want 10 elements. And then simply hit the cancel button. And even though these are showing an error now, they aren't. This only verifies when you make a change. And the easiest way to see that is we're just going to close Prog 1. Now, I did not say the PLC program. I just said this tab. And we are going to click yes to save it. And we'll open it right back up. And now our errors are gone there. We scroll down, we're going to do the same thing here. So double click on one of the go look for our ones for the output. And we are going to take that section out. We'll make this a dent, and this will be a dimension of 0.9, which gives us an array dim 0 of 10, and then hit the cancel button. And same deal, we're just going to close that and open it right back up. And there you go. That fixes those. Now see how all this is truncated. Remember, we can right click over here in the white space to the right of our ladder. It's going to bring up our properties and change your element width to about 6. That way we can read the words. We need a 7. And now if we close that out, there we go. Now we can read everything that's going on. Now, same as the previous video, that is all the instructions we're doing here. But now we're going to set this one up for Modbus. So we are going to double click on our Micro 850 at the top, which, we do need to name. So let's open up Factory Talk Links so we can review why we're doing this. Is we have 4 PLCs on our network now. And here's a good example about these boxes marching. And a lot of my troubleshooting videos, I tell you, make sure your boxes are marching if you can't go online. Notice this one down here says Micro 850. But we changed this to our Festo main. I feel confident we did. So if I click on the word Ethernet, that's going to get that animation going and immediately see that updated to Fest domain. But by having these names here, that's going to help us out while we're troubleshooting. Now, our conveyor is 192.168.122, which we're going to need in just a second. And yeah, we want to call that conveyor. And that is right here. So right click the Micro850 and let's rename it to conveyor. And then double click on it. And we need to set the conveyor's IP address first because it defaults to DHCP. And it is going to be 192.168.122 with the subnet of 255.255.255.0. And I'm going to put a gateway in because I'm doing some networking videos, but this is unnecessary for your application. I'm going to put 192.168.1.1. Okay, now right below it, we have Modbus mapping. And so this, if you use it, is going to make this the Modbus server. And I struggle a little bit with the whole client server model, but the big thing to remember is the server is the place that actually holds the data. The client is the thing that goes and reads and writes to the data. So we are going to make this one the server, and that's what we're doing right here. Now, right here it says to communicate via Ethernet, ensure Modbus TCP server is enabled. And we click here, which actually is just going to take us right back to this Ethernet page. Then if we go down a little bit, we have Modbus TCP, and we want to enable that. Now, that error does not go away, or warning. It's always there, so don't worry about that it's showing up right now. But now we want to add some data. We'll hit the add button. And now we want to go find our tags. And I'm going to go down here. I'm going to go up here. I'm going to go down here. Oh, I made a mistake, but that's okay. We might as well learn a little bit about scopes while we're at it. Is the way I copied and pasted those in, it ended up on the scope of Prog 1. There's what I was looking for. But let's hit cancel, just make sure we understand that. So when we double click on the global variables, that's kind of wherever our IO is and all our system things. And for a lot of message instructions, it is the only place they can be to go find stuff. And then under each program, we have local variables. These are localized just to this. And since the way I created these, they ended up in Prog 1 scope. But we can still use them. Let's go right back to our conveyor tab and hit the add button again. And on our scope, let's put Prog 1 in. And we want our inputs, and we're going to click OK. And this is going to put it into what we usually call the 40,000s, but notice in connected components, it is the 400,000s. And this is what we consider a Modbus holding register. Modbus is a really interesting protocol because it is kind of what we call the universal protocol because almost anything can use it. But even now, I am in Southwest Virginia. You may be in some other place in the world. We speak the same language, but you may be listening to me being like, I do not half understand what this guy is saying. And Modbus is the same way. So I always say, Modbus, you can kind of put your message, fold it up into a paper airplane, and we can toss it across the fence. And the other PLC probably will grab it. Now, we have no idea for sure how it's going to actually file it. So when it comes to these 4,000, 3,000s, and when it comes to in Modbus, is it a 0 or is it a 1 as far as the position? There's a lot of work we got to do. And we may even run to this from Micro800 to Micro800 because honestly, I haven't done this before. I've done Micro800 to control logics over Modbus, but this is my first time. So that gets our inputs, and now we're going to add again, and we're going to go back to our Prog 1 scope, and we will grab our outputs. Now notice it gets them nice and tightly packed. If you feel that one day you may want to make some modifications, or you want to make it really clear what inputs and outputs are, or for any other reason, we can simply change this number, hit the enter key, and it's going to change it there. And this is all the setup that I believe we need to do in our server of Modbus Data PLC. So let's go ahead and download this. Now let's be careful here Remember, we do not have a connection path yet. So we do need to select the right PLC. So hit your download button and go into Ethernet and make sure you select the Conveyor PLC. This can get really confusing, especially when we start messaging back and forth. But 192, 168, 122 in the case of what we're doing is going to be our PLC. So click OK to that one. Oh, well, and I have not actually used this PLC yet. We're running version 21 and the current one is 20. So we do need to update and download. It will not take long. And the biggest thing while this is updating is do not mess with your computer. In other words, don't be checking your email. Don't be flipping around on Facebook. Don't be watching YouTube. Although if you are, I hope you've hit that subscribe button. But just let this do its thing, because if you interrupt a firmware update, then you can end up what we call a brick. And that's because pretty much it is as worthless as a brick at that point and will not function anymore. Then we can go ahead and put this back into run mode. And remember from our previous video, we actually couldn't be connected with more than one PLC at a time. So we are going to need to disconnect from this PLC before we can actually move on to the main PLC. So let's go ahead and just disconnect. And then we'll go over here to our main PLC. And I still have my SIP messaging and our copy instructions, but we're going to go ahead and bring down a new rung and bring down an instruction block. And we're going to double click. And we want to look for Modbus. And you're going to have two options. We're going to have Modbus and Modbus 2. And Modbus is RTU, and that is serial communications. And actually, we can do that with this. We do have videos on that. And then we have Modbus TCP, and that's over Ethernet. That's what we're going to do this time. So we'll select it. And then let's go ahead and start building out our read first, because once you can read, we can figure out how to write. So I'm going to double click here, and we're going to put read cancel. And then for local config, I'm going to put, actually, I'm not thinking far enough ahead with my strategy here, because even up here, I just put read and write. And so this was the handling. Well, now we're on the conveyor. So actually, we need to do better than this. Now, I'm not going to get really deep. I'm just going to put read CONV. Yeah, read CONV cancel. Then we'll have read CONV local. Then we'll have read CONV target. Then we'll have read CONV address, read CONV error, read CONV error ID, read CONV error sub ID, read CONV sub error, and read CONV status bits. All right, now let's highlight the message instruction itself and hit the F1 key to bring up the help. Actually, we still have all our other help from the CIP messaging. Let's clean up a little bit here. There we go. And there are a couple that we need to have open. We have the main one here. And then over on the side, we have local parameters and target parameters. Right-click your local parameters, open a new tab. Right-click your target parameters, open a new tab. And if we scroll down just a little bit, first we have simply cancel. And we probably won't use it, but why not make a tag for it? Then we have our local config, and that's why now we have our local parameter tab. Click it. And the first thing is the channel number. And so for ours, 4 is going to be the channel number. That is the Ethernet port. So we'll go back over here, double click on the local config, open it up. And so our local channel, our project value, I'm going to put a value of 4 in. And then we have our trigger type. And same as our SIP messaging, it is, do you just want this to trigger once when this instruction comes true? Or do we want it to repeat itself? And we're going to do the repeat. I'm going to go ahead and throw 20 at it just because that is what we did in the previous video. Now, the Modbus command can get a little complicated, but we want to pay attention to this number over here. So if we go back to what we just created, and we look at our Modbus data, these are in the 400,000s. Now, typically the documentation will say, in this case, 40,000. That's more common, but this is it. So we want a Modbus command of 3 to go read these holding registers. So we'll go back over here and we will use a command of 3. And then we have an element count. If we go down, if we are reading registers, it's going to be in words. And words are 16-bit numbers. Now, if we go back over to the program we just made, that is what these numbers here actually are, because we only have 10 double integers. Each one of these takes up 2 words, though. So that is going to be 20 words. So we want to go back over here and change that to a 20. Now let's go to our target config. Now be really careful here, because I've done it several times in this series. Don't hit the OK button here. These numbers did go in. We're going to hit the cancel though, because otherwise it's just going to change this right here. Now let's double click on our target config and open it up. And this is where it can start to get a little confusing with Modbus. And honestly, I'm really not sure how this is going to land. We will wait and see. But first, we have an address and we have a node address. So let's go back to our help and go to our target parameters. And our address, this is the number we want to go find on the server. Now, notice our numbers over in our program are 400,001 through 400,020. When you're talking about Modbus, this first number actually has more to do with how you identify it. You actually ignore it. So it appears that we want to put a 1 in for the address. Now, I just did a video on this with another TCP device, and I still get confused on this right here. But it says decreases by 1 when sending. And so, yeah, we may be backing up and punting in a second, but at least the way I read this, if I want to read address number 1, then I am going to need to put a 2 in there. So we're going to go over here, and for our address value, we're going to enter a value of 2. Now, next we have our node address. This is the IP address. So for ours, this is the IP address that we want to go read. And our conveyor is 192.168.122. So we'll go over here. We're going to open up our node address. And for our parameters, we are going to enter, let me just widen this up a little bit so we can see. These are the 4 octets. The first number we're going to enter is 192. The second number we're going to enter is 168. The third number we're going to enter is, oops, what did I just do? All right. Well, we ended up back where we needed to be. I did mess up right there, but we'll go fix that in a second. 192, 168, 1. So 22. All right, since I did mess up, I'm going to hit the cancel button because here, well, since I've already done it, let me show you. So you see right now, this address here is messed up, and that's what happens when you hit the OK button. Now, this still needed to be the read conveyor target. So I'm just going to double click, and we'll select the whole thing and click OK. That's going to fix that, and we'll double click right back into it, and we'll open it up. And the next one is the port. Now let's talk about this a little bit, because typically you don't have to enter it, but I want us to understand why. So Modbus standard TCP port number is 502, but if you set it to 0, which is its default value, if you haven't set it, it's going to default to 502. The same with our unit ID. If we're not bridging, you can leave it at 0. Our timeout, if you set it to 0, it's going to default to 3000. And our connection timeout, if you set it to 0, it's going to default to 5000. And typically we don't need our closure connection, so we don't need to deal with that. All right, now there is another issue, and you guys hopefully followed along from the SIP messaging. That way we don't have to fight too much about this. Is we also have this issue where when this message executes, it's going to immediately clear our data out. And we already learned about that up here, but a lot of you are coming here without going through those. So let's go and download this program. Okay, and we have an error. It says error ID of 130, no sub error ID. So let's go over here and go back to our Modbus 2 and look down at our errors and see what error number 130 is. It says illegal data address. And I promise you, it is that subtraction number. Sometimes you have to, and here's the part about Modbus, it is kind of throw the paper airplane across the fence and see how the other product responds. But I will almost bet that we go here to our read conveyor target and we open it up. And right now I have that target addresses too. And still, when I come over here and I look at this, I still swear it says decreases by 1 when sending. And we want to get data address 1. I swear still it should be, I don't know. This is one that Modbus will continue to baffle you for your entire career. But if we go back over here, in fact, I'll get it where we can see it. I bet you magically this error is going to go away when I change my target address from 2. There you go. It went away. And I will never understand that. Now, we still got a little bit more to do because there's probably still a few more challenges. Well, we have the copy challenge, and we already know this, but let's go put some data in our other PLCs so that we can be looking for something. And so I am going to disconnect from this PLC because in Connect Components, you can only be connected to one at a time. Don't ask me why in the comments. And let's go to our conveyor and we are going to connect to it. And now we have these mapped, but just so we can make it a little easier and figure out for sure what's going on, is let's open up our local variables and we are looking for the inputs from the main PLC. And actually, I'm going to go down here to number 2. And I'm just going to put in 1, 2, 3, 4, 5. And that way we have something to look at. We'll disconnect from this one. We'll go back over to our Festo main PLC and reconnect to it. And our read error at least says it's false. And if we look at our read conveyor address, and honestly, I do not know if our response time no, we do have it. And, honestly, maybe we don't need the copy in this one. See, we had to have the copy in the other because when it goes to read, it clears it all out. That looks really steady, though. All right, I do need to go to the help and make sure here. Just so you know, when you execute the CIP symbolic read, this is on the right, but when you do that, it clears all the data to 0. And then once it's done, it refills the data. But let's make sure on this one. Maybe you don't need that on this one. So if we go down here and we go back to our read and we go up to our data local address. The other one has a note that it clears it out. There is no note here. So they actually, okay, and here's where sometimes you find out Modbus may be the easier way on this. If I need to add or subtract a 1, that may be the most difficult part. But all right, now that we're reading, writing will be a lot easier. Always try to read data first because read data kind of tells you have your path right and all that type of stuff. When it goes to write, there could be other permission issues, things like that. But all right, let's go ahead and go back offline. And we are going to right click rung 5 and copy it. And we will just right click and we will paste it. And actually, I'm going to drag that down because this will be the second one. All right, and on every one of these, I'm just going to double click in. And where it says read, I'm going to put write. And then, yes, we do have an error there, but we just double click on the bottom, click OK, and they're going to be good. So go ahead and do that on all of them. And now we need to go fill some data in on these. Now the cancel we didn't need to worry about, but let's go to our local config and let's pop open our read config. That way we can hopefully use some of it. And so we had our read channel of 4. we're going to do the 20 millisecond again. And we got this command. We need to go work on it. And then we have the element count. So they're all going to be the same except for the command. So let's go ahead and put 4, 20, skip 1, and then 20. So we'll put 4, 20. We'll skip 1, and we'll put 20. And then let's talk about this command here. So let's go back to our help. Right now we do have a 3 on our read, and it does work. And if we go to our local parameters, 3 is read holding registers. And now we want to write to a register. Now, here's where it gets confusing because we have write single register. That would write to just one. We want to write to a block of them. So that's going to be write multiple registers, which means our command code needs to be a 16. Go over here and we'll put a 16 into our command. All right, remember, hit the cancel button to get out of this. Don't hit the OK button. And now let's double click on our target and we'll open up our read again. And our target address. All right, let's go ahead and fix this one because now we know our target address needed to be 1. And here's where insanity breaks just completely free. And Modbus is, yeah, it seems like we're always adding or subtracting 1. But now we know it's the exact number that we put on our conveyor. So we can go over to our conveyor. And for what we are writing to our PLC, that will be 21. So let's go over here. And we should be able to go to our write message. And our target address should be 21. And then we have our node address. This is going to be the exact same, 192.168.122. So we'll open this up, 192.168.122. And we'll click, oh, almost did it. Don't click the OK button. Just hit cancel there. All right, and then we have our write addresses. Now, this one will need a copy, and here is why. In fact, in the end, this one needs a copy, but we're kind of, actually, well, let me look here again before I say that, because this is, yeah, we actually do need a copy on this one. And we have some videos coming up that actually probably nails exactly what this is. So we're going to leave that one alone. We're going to do a copy on this one. And we'll explain why in a future video. So I'm going to bring down a new rung and another instruction block. And we are going to put in a COP copy instruction. And our source is going to be our our destination is going to be our write conveyor address. So we will put that in our destination. And we need to create our source. So this is going to be our conveyor outputs. And that will be a double integer. And it does need to be an array. And to make it line up with what's over there, we're going to make it 0 and 9. And we'll go ahead and hit the enter key. And then click OK. And so our source offset will be 0. Our destination offset will be 0. And all right, the length, let's go ahead and hit this length again because this confuses people every time, is your length is based on the number of destination elements. So there are 16 bits in a word, which is what this is. Our conveyor outputs are double integers, and there's going to be 32 in it. So even though this is a size 10, our length is going to be 20 because it's based on this number. We're going to leave the swap alone for now. We may have a learning opportunity in a second here, but let's go ahead and download this. All right, and we do have an error on this one. We're getting that error 130 again. If you mean to tell me on one of them we have to add and one of them we don't, and well, that's probably what they're telling me, but okay. We already know that error code number 130 is the same thing we were dealing with last time. And just to refresh really fast, that was illegal data address. And so over here, oh, it is illegal. Because remember, I was sitting here talking to you, telling you how you could change this. This is not 21. This is 1021. My address is wrong. So we'll go back over here and let's go ahead and just double click on our target config. and open it up. And this number should be 1021. In fact, let's see if I can get this where we can see it when I hit the enter key. So right now we have the 130, we hit enter. And yes, okay. So these addresses here are one of the most difficult things to figure out in Modbus. But yeah, that was just an oversight on my part there. Now, if we've done everything right, we should be able to go into our conveyor outputs. And from our exercises earlier, the conveyor run is connected to bit number 5 or output 5. So if I open this up and I put a 1 or a checkbox in output 05, we should see this conveyor start running. All right, so it did not work, and I'm guessing this has to do with that swap bit. And if you remember that from the last video, that was because the top 16 and the bottom 16 were swapped. Okay, let's check it beforehand, though, because 5 plus 16 would be 21. I go down here to 21 and I check that. It starts to run, and same as up here, we needed this swap to be true. So right now, we know that it should be output number 5. But because we have that 16-bit swap going on, it's output number 21. So let's go offline, and we will simply change this swap here to true and just type the word true. You don't have to create a tag or anything. Now, while we're at it, let's go ahead and fix my target config, because when we download this, it is going to download these project values again. So let's put that back at 1021. I'm going to go ahead and hit the cancel button on that and download. And now if we double click on our conveyor outputs and we open up array element 0 and we check the 5th box, ooh, then it does not work. And unfortunately, I already know what this issue is. And we are going to have to break out to another video for this, because this is that other swap issue where we were saying we needed a Studio 5000 swap byte. And that's because the way this swap is working, and I kind of understand why. In fact, yeah, we're just going to have to break out into another video, but we're going to take this number, we're going to add it 5, we're going to add 8 to it. That's going to be, well, 5 plus 8. It's lunchtime. That's going to be 13. I bet you 13. Yep. 13 is making that conveyor run now. So this swap is not working correct. And honestly, I have had so many of you ask questions about this whole swap thing that we do need to break this out into one more video before we talk about how we're going to integrate this. So click here for a playlist that includes it.